we're going to look at some special cases with factoring and kind of identifying what strategy you should use when. I'm going to do the problems out of order. I'm going to start with problem B. I notice that this only has two terms, the 12x squared and the minus 16x. I also notice that these have what's called a common factor. Both of these terms have an x in them, so I can take out an x, and you can think about like dividing by an x or taking out an x. And all these numbers can be divided by 4. 12 can be divided by 4, and 16 can be divided by 4. So now I see what my common factor is, and I'm going to use the greatest common factor strategy. I'm going to take out the 4x and write what's left after I divide by 4x. 12 divided by 3 would be, or divided by 4 would be 3. And an x squared, if you took out an x, you would decrease an exponent to just be a single x. Minus 16 divided by 4 is 4. And x divided by x either cancels out or taking out that x leaves it not there anymore. And this is my final answer. I used greatest common factor strategy to take out a 4x. Similar thing in problem D. When I look at this, I notice that 40 and 100 can both be divided by something. They can be divided by 10. They can be divided by 5 and 2. Your job is to pick the greatest number that they can be divided by. In this case, they can both be divided by 20. And so taking out that 20 is called the greatest common factor. And so 20 times what would get us back to that original equation? So 40 divided by 20 is 2. And 100m divided by 20 is 5m. And this is my final answer for factoring. And I could check my answer by remultiplying. 20 times 2 is 40, and 20 times minus 5m is 100m. These other two problems are not a greatest common factor. When I look at problem C, 3, 8, and 10, they don't all have the same number that they can be divided by. So if there isn't a greatest common factor, we need to use the rectangle and diamond strategy. One thing I want you to notice is that these items are listed out of order. In terms of placement in the diamond and rectangle, you always want the one with the squared to come first. So we need the 8k squared to be first, then the minus 10k, then the plus 3. In general, the formatting is ax squared plus bx plus c. So you're kind of watching the exponent on the x decrease from squared to a single x to no x's. So now that we've moved that 3 kind of to the back where it belongs, now we can use factoring. As a reminder of how the diamond and rectangle work, the first and the last, or the squared and the one with no x's, go into the diagonal. And then we multiply this diagonal together and put it into our diamond problem. 8 times 3 is 24, k squared. The opposite diagonal also multiplies to that same 24 k squared, but when you combine the like terms, it should add up to this number, the negative 10k. So that goes in the bottom of our rectangle, negative 10k. Then we're asking ourselves what two numbers multiply to 24 but add to negative 10. Sometimes it's helpful to make a little list. 24 is 24 times 1, 12 times 2, 6 times 4, 3 times 8, and I think that's it. So which one of these could add up to negative 10? 12 and 2 could turn into 10, or 6 and 4 could turn into 10. And we have to place the negatives in there correctly. When they multiply, I need a positive. The only way for that to happen is two negatives multiplied together and make a positive. So I need two negatives to multiply to a positive. then now my only option is negative 6k and negative 4k. That will add to negative 10th, but multiply to positive 24. So those go into our missing rectangle spots, negative 6k, negative 4k. And then we look across the directions of the rectangle to take out what they have in common that would have multiplied in to make those positions. So for example, here the 8k and the 4k both have a 4 and a k. So we'll have a 4k. And to finish making that 8k box, we'd have 4k times 2k to make 8k squared. And then that 4k to make negative 4k would need to multiply by a negative 1. Looking upwards, 2k multiplied by negative 3 would make negative 6k, and negative 3 times negative 1 is positive 3. So to write our final answer for factoring, we take what we see in the parentheses, or on the outsides, and write them in parentheses. Our final answer is 2k minus 1 multiplied by 4k minus 3. I'll do one more example and then you'll finish the rest on your own. Here I notice 9 and 4, they don't have anything in common that they can be divided by, so it's not a greatest common factor. So I'm going to have to use the rectangle and diamond strategy. But it doesn't have all three pieces. It doesn't have the ax squared plus bx plus c. It has the ax squared, it has the 9x squared, and it has the plus 4, but it's missing this piece with the x. So we're just going to rewrite this by putting in that there are 0x pieces. 9x squared, there are 0x pieces, and then minus 4. So now I have all three terms in order, and it can help me fill in my diamond and rectangle. The 9x squared and the minus 4 go into the diagonal, and then they get multiplied and placed in our diamond problem. 9x squared and minus 4, and if I multiply those, I get negative 36x squared. Then the opposite diagonal will multiply that as well, but I also have to combine the like terms and have it add up to 0x. So I'll put 0x in the bottom of my diamond problem. Anytime it adds up to 0, it's because your two numbers are opposites. In this case, to multiply to 36, you would need positive 6 and negative 6. Positive 6 times negative 6 is 36, and positive 6 minus 6 is 0. Don't forget to put the x's there with them so that it's factors and adds and multiplies correctly. Put those into your rectangle, 6x, negative 6x, and then start looking for what tiles would multiply in to make these boxes. Let's see, going across the bottom here, both of these numbers can be divided by 3, and they both have an x in them, so we'll put a 3x. And 3x multiplied by another 3x would make 9x squared. And 3x multiplied by negative 2 would make negative 6x squared. 3x multiplied by 2 would make positive 6x. And then we can double check this positive 2 times negative 2 is negative 4. And those arrows are just kind of showing you how the boxes get multiplied and where they're coming from. So our final answer is what we see on the outside here. 3x minus 2 as a length times 3x plus 2 as a width. And that is our factored answer. So you're going to try 3 more factoring problems on the next page and some basic solve for x examples.